My name is George Kopolov. I'm a red steel carpenter with Manitoulin timber frames, and today we are on top of McLean's Mountain on the property of Northland Power. And behind me you can see the ceremonial building that the wind farm has tasked us with building. Come on in. This building is used by the First Nation elders 4 times a year for their ceremonies at solstices and equinoxes. When we were designing this, the main idea was to make the design as culturally appropriate as possible, simultaneously adhering to all the engineering requirements and the building code, which is quite a fine balance. Traditionally, buildings like this, the posts would be just dug into the ground, and just dig the posts into the ground, put the roof on top. Nowadays, it is not considered a very long-term solution because the posts can rot at the base and then the whole thing topples over. What we had to do here is we strip layer of topsoil, and we've poured a circular footing underneath the perimeter, 8 cubic meters of concrete. So the boulders that you see, we had to go into a farmer's field and pick them out one by one. You know, like we'd come to the boulder and be like, is this gonna look good? Like, how is this character? Is the size all right? Is the shape? We filtered through, I don't know, I think we handled twice as many boulders as you see here. Like these 2 guys, they have a flat surface, and we oriented them so that, you know, a wheelchair can get through. A lot of thought like that. It looked a bit ridiculous to the excavator guy who was helping us. He's like, okay, where's this one going? Like, well, yeah, let's see. Well, it doesn't speak to me. He's like, come on, get this done. Maybe half of the boulder is embedded into solid concrete. It's 12 inches deep, and the rest of it you can see. And we drilled a hole in each boulder, and we've epoxied a stainless steel rod into the stone and up into the base of the post. So the posts have holes drilled in the ends, and we filled out with epoxy too, so that when they go on, the idea is that if a tornado comes around, it's not going to be able to lift the whole building off. And the secondary challenge is that traditionally all the joinery up above wouldn't be as bulky in this area of North America. First Nation people would generally lash poles together with twine, so they wouldn't employ any kind of joinery. It would be just, you know, one on top of the other, tied together. So we had to use some state-of-the-art steel fasteners. So we used some big 10-inch screws. I think there are 1, 2, 3, 4, 6 in every joint. The idea behind this whole building is that it should be as environmentally conscious as humanly possible. In order to do that, I thought, okay, we have to get local wood. That's a no-brainer. So this is all eastern white cedar that's been harvested within a 100-kilometer radius. And then we worked with a sawyer to mill the logs into planks for us, specifically like taking into to exaggerate the curve of the tree. We would cut off the bark, following the grain. Like here, for example, you can see that this line is not straight, but on the bandsaw we followed the grain of the board. So, and then, you know, the next board goes to it, scribe, goes to it, scribe. We didn't want to fit it all perfectly because all these boards are green, which means that as they age, they will lose moisture and they will shrink. So we knew that the gaps are going to open up. So instead of trying to achieve perfection in a fleeting moment of time, we decided to just work with the material and just make gaps part of the finished look. You can actually see these checks in the wood is the sign that the wood is drying, because what happens is that the log in the round, it starts drying on the outside. So when the wood dries, it shrinks. So the outer layer shrinks first, while the inner layer is still wet, moist, and full size. So what happens is like the skin gets tighter and tighter and tighter, has no place to go. So it checks and releases some of that pressure. It's not a structural defect. In fact, you know, you can go into a building, timber frame building that's 800 years old, and you will see checks in the beams, but it's solid, as long as it's protected from the weather. So the idea behind this building was to make it look as natural and feel as natural as possible. So the key to that was to make it look like the posts grow out of the boulders. So we've spent quite a bit of time really scribing the bases of posts to the stone, and we had the excavator suspend the log in midair and just kind of hover it atop the boulder. Because there's a pin inside, we'd use it as a kind of guide point, rotate the log how it would look best, and then scribe it. A couple of logs we got first time, but some of them we had to like do 3 and 4 times. Ah, damn. Yeah, misscribed, miscut, don't know what happened, didn't fit. Anyway, it's a bit of an effort, but I'm really happy how it turned out. Grooves on the underside of the railing and tuck the boards in so that when the boards dry they would naturally cup or twist, but once they're in the groove is restricting them from doing that, so they will stay flatter as they dry. Meaning of the 4 posts in the center, they represent the 4 directions and 4 times of the year, and on the outside the 13 posts represent the 13 moons of the year. And the boulders, we call them boulders. First Nation people refer to them as grandfathers. So we were not placing boulders, we were placing grandfathers to carry the building. Yes. This building is oriented in a very specific way. The doorway is facing directly east, which is the direction of the beginning in the Anishinaabe culture. It is represented by the color yellow, and around us you can see yellow for the east, red for the south, blue for the west, and white for the north. The flags are tied everywhere where a prayer has been said in a specific way, and then the flag is tied. If you go into the bush a little bit, you will see more and more flags, and the area is considered sacred to the extent that the flags are hung on the trees. Yeah, so for the roofing material, this is just awesome. I think it's the highlight of my whole career. This is cedar bark shingles. So what we did with the logs, we had to peel them all off by hand with a big draw knife to achieve this finish. And when you peel logs, you have all the bark left over, which is considered waste by pretty much everyone, except us. When we were designing this building, the idea to make it as culturally appropriate as possible, everything that I could find on First Nations building practices in the Great Lakes area is that they covered all their buildings with some type of bark. Further south in Ontario, it's ash was used a lot, and other hardwood trees, birch bark canoes, big chunks of bark. In this area, we don't have any hardwood trees that are big enough for that, and that would be willing to fell just for the bark alone. So we had a lot of cedar. Cedar had a lot of bark. So we spent about 3 days just stripping poles and chopping the bark into 16-inch lengths, and then making like bundles with it. We made 24 bundles, and we're like, oh, hope that's enough, because there was only a very small time window in the year when the bark comes off easily from the log. It's generally around the time when the black flies come out. This is not the most long-term solution. Like, this roof will not last 20 years. It will have to be replaced sooner than that, and we were quite okay with it because it is such a low environmental impact. To make the shingles last as long as possible, however, we've installed First off, we've installed a ice and water shield, so it's a very modern, high-tech membrane that seals around all fasteners that go through it. Heats up in the sun, goes and seals all the nail holes. So even if the shingles all blow off, the roof will still not leak. After the ice and water shield, we've installed what's called a cedar breather membrane. You can't really see it, but you can see there's a slight gap between the shingles and the roof edge. So it's this extruded, looks like a spider's web type of plasticky material that gives us a tiny air gap between the bottom of the shingle and the top of the roofing, so that not if, but when the water gets behind the shingle, it doesn't just sit there and rot the shingle from the underside. It has room to escape, so the shingles breathe from underneath. All of these roof framing members are technically hip rafters, and a hip rafter is a roof framing member that is in between two separate roof planes. In this building we have 13 roof planes, so every rafter has a, you can see it has a angle up here cut into it. So this surface and that surface, there are two different surfaces. So when we were designing this, I thought, okay, we have to really get this right because it's gonna look really sharp, just like that. So we had the sawyer fabricate a jig, so he would make one pass as you normally would on a sawmill, and then we had to rotate the log 7 degrees and make the second pass so that, you know, the two planes meet. And yeah, and then place all of these rafters on by eye basically, and make it work. This has been a really unique project for us at Manitoulin Timber Frames. We really specialize in traditional timber framing. That's mortise and tenon joinery, pegged together with hardwood pegs. We really like to make every building unique and make it, I don't know, make people happy every time they walk into their space and make it a work of art. We also do general carpentry, like we can install windows and build decks, things like this. And we also install steel roofing. You can find us online at manitoulintimberframes.ca, and we're also on Facebook.
Hey everybody, it's Forrest the Filmmaker. Hope you guys enjoyed that episode of Alternative Dwellings. If you want to see more, playlists are popping up right now where you can watch all of our archived episodes. Or if you want to see new ones, make sure to subscribe because they premiere at 7:30 a.m. Pacific Standard Time every single Monday. Hope to see you guys there.